Lecture number 4 in our organic class, and we talk about addition to alpha beta unsaturated carbonyl compound. So the first reaction is so important reaction related with this subject in inorganic chemistry is the Michael reaction. Michael reactions, of course, give you carbon-carbon new bond. Involve nucleophilic addition of carbanion or another nucleophile to the alpha-beta unsaturated carbonyl compound. This is the system for the carbanion. It will be added to the alpha-beta unsaturated carbonyl compound. So now 1,4 addition to alpha-beta unsaturated carbonyl compound, the carbanion, it will be added to this 4 atom system. So 4 atoms, they are all of them related to this addition with carbanion. So the carbanion, it will be added to this carbon, and this it will be converted to here. I will explain the mechanism to give you this compound. So if you look here, 1, 2, 3, 4, 5, 1,5 dicarbonyl compound, 1,5 dicarbonyl compound. So to have the Michael reaction, you need 2 main components to make these reactions. The Michael donor, a nucleophile, usually a resonance stabilized carbanion. Carbanion must be stable. Common examples included the malonate, cyanoacetate, or the beta-ketoester. All of them, they have resonance stabilization. So the Michael acceptor here, the Michael acceptor is an activated alkene. So typically alpha-beta unsaturated carbonyl compound like an enone, enal, or nitroalkene. So the electron withdrawing group, this is the electron withdrawing group here, activated the double bond for attack. So when you have here electron withdrawing group, it will be play good role to activate this the double bond. So the mechanism, if they say the enolate anion 1 may be principle be generated from any enolizable carbonyl compound 4 by treatment with the base, the reaction work especially with beta dicarbonyl compound. The enolate 1, it will be added here, said here. So the first we will must be this step to generation of the carbanion, to make the carbanion. So the carbanion 1, here the carbanion 1 to be added to this carbon for the alpha-beta unsaturated compound, and this pi bond make double bond here, and the pi bond here between carbon and oxygen will be open to the oxygen, and the oxygen will be bear a negative charge. So finally, negative charge make a double bond, and this is the double bond here. It will be open to make to take a proton from the solvent. So the Michael reaction is matter because it's allow for construction of complex molecules by joining 2 smaller pieces here with high control. So the product it has a big structure, high molecular weight. So and Michael reaction is the first step in the Robinson annulation. This another reaction type of reaction. We will take it inshallah. So he said the first step from the Robinson annulation is the Michael addition. So a famous طبعا sequence used to build a sequence here, meaning Robinson annulation. It is not just one reaction, 2-step reaction or more than 2-step reaction, يعني multi-step reactions, multi-step synthesis reactions. So used to build a fused ring system to bring the fused rings. So if you use a very strong nucleophile like green reagent, you might get 1,2 addition instead to the Michael addition usually require a soft nucleophile, not very strong nucleophile, or a specific catalyst to ensure that it will be attack position number 4. Okay, so because our carbanions they are stable by resonance or by another factor, so it will be not very strong nucleophile. Okay. Now, if you look to this example here, what we have here, we have this compound, and this proton is acidic. So by using base can be remove this proton to generate the carbanion, and the carbanion will be added to this position here, not this position. Okay, this position, and it will be give you the product. It will be give you the product under the same mechanism, during same mechanism. So look to this example also. By the base it will be carbanion, so the carbanion here to be add to this carbon. So we have here between this with this carbon, we have carbon-carbon new bond, carbon-carbon and new bond. This is the carbon-carbon new bond. This the carbon-carbon new bond. Another example here, the base remove proton and carbanion it will be added to here to give you this structure. Look, from small molecules we will get big molecular weight compound. Another example here, if you remove this proton, this it will be attacked to here, and this it will be converted to here and take a proton again to give you this product. Okay, to give this a product. All of them they are Michael addition. Also here, by a base can be removed and will be added to here. This is the same example for this, okay, but with different carbanion, with different carbanion. So here, what he said, give you LDI here, the lithium diisopropylamide is the base here, the base, okay, the base. So the base uses to remove proton from the carbonyl compound. Another example here. Also here can be generated the carbanion, and the carbanion will be added to here to give you this compound. So the second reaction related with one alpha beta unsaturated carbonyl compound is the Robinson annulation. Annulation meaning make the aromatic compound or make the cyclic compound here. The Robinson annulation here is a classical 2-for-1 reaction in organic chemistry. So it is two-step reaction, but in one process, two-step reaction in one process. So it is tandem sequence that build a new 6-member ring, alpha beta unsaturated cyclic ketone. Look, the product here, it is alpha beta unsaturated ketone into an existing molecule. So look to the first one, here. So with the base it will be give you carbanion from here or from here, no different. And so the carbanion will be added to this molecule to give you this product. So the second step here is the annulation. It is like coupling between diketone compound. So also it will be generate carbanion from here, and this it will be added to here. So and it will be give you remove H2O from here to give you condensation type reaction to give you unsaturated compound. So if you look here, this first step is Michael reaction, and the second step between coupling between two carbonyl compound is the aldol reaction. Here. So it is two-step process. Michael addition, the reaction begins with Michael addition, 1,4 addition, a nucleophile, usually a ketone attack Michael acceptor, typically methyl vinyl ketone. So this form 1,5 diketone intermediate. This 1,5, 1, 2, 3, 4, 5, 1,5 diketone compound. So secondly, diketone in the same molecule, that meaning it is aldol reaction here, condensation reaction type. It will be intramolecular aldol condensation. So the mechanism of the reaction, if you offer the reaction, so it's easy mechanism, not so difficult. The base remove a proton, and the carbanion here, it will be add to alpha beta unsaturated compound to give you this intermediate, remove H2O, to give you this compound, ketoenol fluorine, ketoenol tautomerism here. The enol, it will be converted to the keto form. So finally, what we have here, we have cyclization. It is aldol reaction, carbanion and carbanion attack this carbonyl to make cyclic compound and remove H2O. This, it will be remove H2O, this OH with this hydrogen, to generate the unsaturated double bond. Unsaturated double bond. So it is a clear mechanism. Try to resolve as homework for you. So why 6-member ring here? Again, we take it before that, the reason why the 6-member ring, it will be formed here, while other ring size are theoretically possible. The 6-member ring, we said it is a sweet spot, easily to make here attack. The conformation for the molecule is very good to make the cyclization in this point here. So the 1,5 diketone structure is perfectly spaced to allow for 6-member transition state during the aldol step. So this is during conformation for the compound. This can be near from here, this position, and easy to make to attack the carbanion to this carbonyl. So again, why it is important, this reaction, the Robinson reaction is famous because it's a great 2 carbon-carbon bond and 1 ring. So we have 2 nuke bonds and 1 cycle. So this is fundamental why chemists called this type of structure. It is very useful to build the steroid, like the cholesterol or testosterone, the hormone in our body. Can be used as a drug, So examples, another examples here. Base, here the base, remove this proton, and carbanion, it will be attack on this side here to give you a 6-member ring cycle, 1, 2, 3, 4, 5, 6, to give you this 6-member ring cycle. Another example here also, look here, this it will be removed, and to give proton here, it will be removed to generate the carbanion attack from here to make a cycle 6-member ring. Another example here, the base remove this proton, and this proton, it will be added to here to alpha beta unsaturated compound. And secondly, also this proton can be removed to generate carbanion, and the carbanion will be attack this carbonyl to give Robinson reaction here to give this product. So where is it here? The base, it will be removed here. It will be remove this proton. So it will be attack the alpha beta unsaturated compound, and finally this proton also, it will be removed carbanion, it will be attack this carbonyl to give you this product. Try to write the mechanism for this reaction. try to write the mechanism for this reaction. This as homework for you. So another related reaction here is the Reformatsky reaction. The Reformatsky reaction is a classical يعني organic reaction used to synthesize the beta hydroxy ester. Beta hydroxy ester, it is involved the condensation of aldehyde or ketone with what? With alpha halo ester. With alpha halo ester in presence of metallic zinc by using zinc. So firstly, alpha halo ester, it will be react with the zinc, the atom zinc, it will be make complex here between the halogen and this carbon to give you this complex. So on this complex here we have this carbon, it is negatively charged, it will be work as carbanion, as nucleophile, and it will be add to this carbonyl compound to give you alcohol, to give you beta alcohol ester compound. So the classical Reformatsky reaction consists of treatment of alpha halo ester with the zinc metal and subsequent reaction with the aldehyde or ketone. This is the classical method. In these days or in early years here, the name is used generally for reactions that involve insertion of the metal into carbon halogen bond and طبعا subsequent here reaction with the electrophile. Formally the Reformatsky reaction is similar to the Grignard reagent. يعني it is like a Grignard reagent because the Grignard reagent used the magnesium to generate the carbanion as a complex. Here we used in Reformatsky reaction we used the zinc metal to make a complex that be used as carbanion. So by reaction of alpha halo ester 1, this with the zinc metal in an inert solvent. طبعا the solvent must be inert like ether, and of course it will be dry ether here, or can be used also tetrahydrofuran, the dioxane, or organic zinc compound 2 here. It will be formed. It is like a Grignard reagent. So it will be add and it will be give you this intermediate. So hydrolysis, take a proton from the water to give you alcohols group. The reaction with carbonyl substrate 3, this here is similar to the Grignard reagent. I told many times it is be like a Grignard reagent. What we have here examples. Look, this is the alpha halo ester and this is the aldehyde. So zinc, it will be entered to here between this brom atom and the carbon to make the complex, and the carbanion, it will be add to this carbonyl group to give you alcohols here, to give you this product. Similar thing here by different starting material. This aldehyde, this ketone, also during the same way to give you the product. Another type of reaction, you know it, also we take it in many steps of our reaction. Here is the decarboxylation, 3-oxocarboxylic acid, decarboxylation of the 3-oxocarboxylic acid, also known as beta-keto ester, is a fundamental organic reaction, unlike most carboxylic acid, which required external heat طبعا to lose the carbon dioxide. We need in this type of reaction always we need heating. Beta keto acid undergo decarboxylation quite readily يعني. Okay, often just by mild heating. Just we used heating can be decarboxylation can be happen. So if you look to our system here is the diacid. Here we have the diacid. Diacid, this is the diacid. So this is the mechanism, of course, here. By using heating here, this the double here the carbon, sorry, the hydrogen oxygen bond. This is the bond. It will be make double bond, and this it will be make double bond here, and the double bond will be open to attack this proton. It will be take it this proton. So we have to lose here this part, oxygen, carbon, oxygen, as what? As carbon dioxide. As carbon dioxide to give you the enol form. طبعا enol form, of course, directly enol form. This is go to the keto form. It is like a proton transfer from here to here to give you carboxylic acid. So beta keto acid, this is the beta keto acid. Okay, it will be give you again enol, and enol. It will be go to the keto form, So diacid give you carboxylic acid, and beta keto acid give you a ketone. So look, this is it is beta keto. This beta carbonyl acid is the acetoacetate. Acetoacetate will be entered to the by heating decarboxylation. So we have to what? We have to remove this here, oxygen, carbon. We have to remove oxygen, carbon, and to give you the product. This hydrogen will be here directly. This hydrogen will be here. So look to this reaction here. Firstly, he used base. Base, what making the base? Base remove the proton here, make carbanion. So secondly, the carbanion will be attack the alkyl halide. This is the alkyl halide to make the R here. Step number 3, hydrolysis, and what? And heating. So the hydrolysis convert the ester group to what? To the acid. To be convert the ester group to the acid. Both of them, this and this, to the acid. And one of them it will be loss CO2. So for example, this it will be loss CO2. This CO2 it will be remove CO2. So what we have here, we have R alkyl group and CH2 and carboxylic acid group. R CH2 and carboxylic acid group. So you have to understand the step here. Step by step. If you look at and you don't know to write this structure, try to resolve one by one. Yani firstly, try to write the product for this step, and the product for this step, and the product for this step, the hydrolysis, and then the heating, the decarboxylation. Okay, step by step. Write it as homework for you, and you will be get this product. Directly you will be get this product. Okay, make it step by step, separated step. This for you. The same thing here. Here, if you look at I already resolved for you this homework. So it will be attack here to make the R group. So hydrolysis, both of them it will be converted to the carboxylic acid, and heating, one of them it will be lost CO2. From this side or from this side, no different. Okay, to give you the product. The same example here. Carboxylation to give you what? But what we have to remove another base, another alkylation to give you on the alpha carbon 2 alkyl group. This example with 2 alkylation. This example with 1 alkylation. Until here, I think the chapter is finished. So please, again, as a note for you, try to resolve all the equations or the reactions. Use your hand, write many reactions on the paper. Also your experience can be improved by writing. So this chapter is finished, and good luck.